Hey everybody, here's your lab video for the ideal gas constant lab. Really important that you have out the data table while we work through this lab so that we can get some information down. Let me kind of set the stage, show you what we have going on. So, I have myself a long strip of magnesium. This isn't that long, and we're going to use magnesium as one of the reactants in our chemical reaction today. The other thing we're going to use is 4 molar hydrochloric acid, so we'll use that in a second, HCl, 4 molar. And then we have a big tub over here that used to be some party mix. It's now just a big tub of water. So this water's been sitting out for a couple of days. It's room temperature. We need that room temperature water in order to do our lab because we have to measure the vapor temperature of water. So we want that water to be at a constant temperature. In fact, let's start off by measuring the temperature of that water. So I have myself here a little thermometer. If I go ahead and put that down into the water, I'm not sure if you guys can see that at home. Let me turn it around. I'm getting a reading of 20.0 degrees Celsius, 20.0, which makes sense because we're right around room temperature, so 20.0 for Celsius makes a lot of sense for room temperature. The other information that I want to tell you is my magnesium. I already cut a strip of it, and I strung up this little device over here on a rubber stopper. I've got a piece of magnesium hanging from a copper thread. Now, I want you to think about activity series, think about hydrochloric acid, think about magnesium, think about copper. The hydrochloric acid should only react with one of those two metals based on the activity series. That's going to be important for us today. But this setup we'll use in a second with this long piece of glass called a eudiometer. The eudiometer is closed at one end. It has an opening on the other end for the stopper. And what we're going to be able to do is collect gas in this device using our water to trap the gas. The other thing that I need to tell you data-wise is the length of this piece of magnesium. So this piece of magnesium that I've strung up on this little piece of copper, the magnesium is 1.41 centimeters long. 1.41 centimeters. And in order to get a mass for that piece of magnesium, let me tell you the mass of an entire meter of magnesium. So if I had an entire meter of magnesium, it would weigh 2.04 grams. 2.04 grams for a single meter. If I have a piece that's only 1.41 centimeters, you guys can figure out the mass of that piece. Okay, we're going to start this thing off. I need goggles, of course. I am going to go ahead and measure up 10 milliliters of my 4 molar hydrochloric acid. I'm not going to measure very precisely because the hydrochloric acid in this reaction is an excess. So the magnesium is actually my limiting reactant. This hydrochloric acid, I need about 10 milliliters to make sure that it's an excess. But the exact volume is rather inconsequential, so we actually don't need to record that volume on our data table. To that hydrochloric acid, I am going to grab some water out of this container to make sure it's the same temperature. And that water I'm going to slowly pour into my eudiometer, and my goal is that the water remains on top of the acid. So I don't want the reaction to start until I have this eudiometer into my container, so that's why I'm pouring slowly here, so that for the most part the water is actually sitting on top of the acid. Now the acid is more dense than the water, so that should help to some degree, but even as we're pouring, obviously those things are going to start to diffuse through one another, they're going to start to mix. I'm going to fill this thing up the whole way to the top, so that when I put my stopper in, I actually displace some water, because I want to measure all of the gas in here. I don't want any gas to start with. The only gas I want to measure is the product of this reaction. And I'm going to use my little trusty device here to add in my magnesium to the top using this rubber stopper. And I should have mentioned earlier, the stopper has 2 holes in it. And so as I flip this into my eudiometer, we'll do that now, the 2 holes will allow water to be displaced. So what we're going to see here is that the acid is going down. It's hard to see on camera, but you can see kind of some oily stuff going down here. And as the acid goes down in this tube, eventually it's going to meet the magnesium, and we're going to see a reaction. So I'm going to hold this up a little bit higher so that, let me turn this for you, so that you guys can see that magnesium. And pretty soon the acid is going to interact with the magnesium, and as the acid interacts with the magnesium, again, we'll see that reaction. While we wait for this to happen, this might be a good time for you guys to write out the reaction that you expect. Again, we're using magnesium, we're using hydrochloric acid, HCl. Think about what type of reaction that should be. Think about what's going to replace what's going to be left by itself. Bear in mind you have diatomics going on here, so be careful with your Brinkelhoff elements, those diatomics. And we'll let this thing get going. So as the acid works its way down my eudiometer tube, eventually it's going to find that magnesium, and we should start to see some bubbles forming. Those bubbles are a gas being released. So I'm just starting to see the first bubbles. You'll see more of this as we progress. Now, bear in mind what's happening because I have this underwater. As those bubbles are forming, we can start to see those bubbles rising up towards the top. And as they rise towards the top, they have to force something out because of pressure, and they're forcing water out through the bottom of this eudiometer tube. Now, it's really important that we're doing this underwater because as the bubbles are forced out, if I just did this out in the air, we wouldn't be able to measure the gas, right? It would have no reason to go up in this tube. So because it's less dense than the water, it's forcing water out while it goes up. And so we're seeing this reaction take place. It should get more vigorous as the acid gets lower in the tube. And we ultimately want to measure the volume of gas that's given off in this reaction. All right, so sit tight with me while this reaction takes place.
Please find this interruption with Seth Williams and Erica Valentine. Please dial extension 2275.
Sorry for that interruption for those of you on video. But sit tight with me while this reaction takes place. And you can see down at the bottom, we're getting pretty vigorous bubbles at the moment, so we're collecting a lot of gas. While we wait for this to continue, let me repeat that data that I gave to you earlier. So we have an amount of magnesium that we're using. It's 1.41 centimeters of magnesium that we're using. The mass of an entire meter of magnesium on your data table, if we had an entire meter, it would weigh 2.04 grams. Again, we're not using an entire meter. We're using 1.41 centimeters, but you can figure out the mass. I can tell you that the temperature of the water we're using is 20.0 degrees Celsius. So we measured that together, 20.0 degrees Celsius. And something else we didn't really discuss is the air pressure right now. So I used just the internet to figure out at a local airport what the air pressure is, because air pressure is really important for pilots to know their specific elevation or their altitude based on their equipment. Their altimeter is based on barometric pressure, so they need to know what the pressure is outside. Is it a rainy day? Is it a sunny day? That affects the barometric pressure. So today, the barometric pressure outside is 762 mmHg, 762 millimeters of mercury. And we're just going to let this thing continue to react. We're getting a bunch of bubbles. I gave a little swirl to hopefully get that acid down there. And as it reacts, hard for you to see, but if I lower this down a bit, oh, you can't see it yet. We're going to see that there is gas at the top of the eudiometer. We have, at the moment, right around 5 milliliters of gas. And we're going to continue this reaction until all of this magnesium is consumed. As I mentioned before, the magnesium is my limiting reactant, so we expect that entire piece of magnesium to disappear. It is getting a little bit smaller as I watch, and you can see the bubbles are becoming a bit more vigorous. So every second that goes by, we're freeing up more and more surface area on that magnesium in order for it to react. All right, stay with me here as we allow this magnesium to continue reacting. We're still giving off bubbles. You can start looking ahead to the questions and the calculations that come up in this lab. So when we calculate, one of the things we're going to have to do is figure out the mass of our magnesium ribbon. I gave you the mass of an entire meter, 2.04 grams. We're only using a small part of that. We're using 1.41 centimeters, so you guys can figure out the mass of that ribbon. You guys can convert that to moles, right? All this stuff we know how to do. So there's quite a bit that has to go on in the calculations part of this lab, and you can get cracking on that now if you'd like, while this reaction continues to happen. So you'll notice that we're still giving off bubbles. I don't know if it's on your screen yet. There it is. So right here, this is the amount of water going down as we're forcing water out of the eudiometer and replacing it with gas. And you can see that the reaction is happening relatively quickly. So we want to continue this reaction until we have no more hydrogen gas. I apologize that you just have to kind of sit there and watch this thing bubble, but relatively soon, once it finishes off, we'll be able to get you that mass of magnesium, excuse me, not mass of magnesium, volume of hydrogen gas that was released as this magnesium was reacted with hydrochloric acid. And it may be hard to see on video, but the magnesium is certainly being consumed by the hydrochloric acid. You can certainly see all of the bubbles rising. And one of the beautiful things about this UDometer tube is that it's graduated. It has numbers on it. And even better, this UDometer is graduated upside down. So 0 is up at the top. We have 0 milliliters of gas, but as this gas is forming, the meniscus is traveling down the tube, but the numbers actually increase. So right here, we just passed 26. It's approaching 27, 28. So these numbers count down, so you can actually, as the gas goes this way, you can actually count numbers as they're increasing the amount of gas being released. And good news for all of us, it looks like the magnesium has been consumed. So we had to let it go for quite a while. And as we take a look at our UDometer here, we can try to figure out exactly how much gas we have given off. Okay, so we can read the UDometer. It's hard for you guys to see there at home. When I get down here and I read my meniscus, we are in the neighborhood of, oh, there's just a tiny piece of magnesium still reacting. Let me let that finish. We are down in the neighborhood of 28.61. So your volume of hydrogen collected is 28.61. I know there's one other thing on your data table, which is the vapor pressure of water, but with Dalton's law, I've given you the temperature, 20.0 degrees Celsius. I've given you the barometric pressure outside, 762 mmHg. So with that information and Dalton's law, you can figure out the vapor pressure of the water itself. All right, thanks for your attention. Have a great day.